Welcome back. Today we are going to learn the Vedic way of division, where we will be learning how to divide any big number with a single digit number. Okay? As usual, you will be able to say the answer just by looking at the problem. Are you ready? Before we start the class, let us say the prayer to zero together. Okay? Fold your hands, close your eyes, and say along with me. Om Purnamadaha Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnamevavasishyate. Slowly open your eyes. Division is the opposite process of multiplication. We have already learned multiplication. So 2 times 3 is 6. This is your multiplication. What is multiplication? Multiplication is repeated addition. Okay, so 2 times 3 means you are adding 2 3 times. 2 plus 2 plus 2 is 6. Okay, and now the reverse process, how we write it is 6 divided by 3 equal to 2. This is your division. Okay, it's like this. Suppose you have 6 chocolates and there are 3 people. You want to distribute these 6 chocolates, 2. And then each person will get how many chocolates? You know, this 6 you divide into 3 parts. So each one will get 2 each. That is your answer. Actually, just like multiplication is repeated addition, division is repeated subtraction. Okay, suppose you have 6 chocolates and there are 3 people sitting in front of you. You have to distribute them. Okay, one baby way of distributing is this. Okay, first take 3 of them. Okay, give this to one person, give this to one person, give this to one person. Okay, check now how many you got. Okay, everybody got 1 chocolate. Okay, again start distribution. Okay, these 3 will distribute. Okay, this you give to this person, this person, this person. Okay, how many everybody got? 2 chocolates. Okay, this is one way of division. You don't need to distribute 1 chocolate each. We are not babies. We know multiplication tables. We know 3 times 2 is 6. Okay, we don't need to give 1 chocolate, 1 chocolate, 1 chocolate. Instead, what we can do? Okay, we can take these 2 chocolates and give to one person, these 2 chocolates to one person, and these 2 chocolates to one person. As simple as this. Therefore, if you have 6 chocolates and 3 people, so everybody will get 2 chocolates. That's all your division. Actually, what we are doing here is we are only seeing how many 3's are there in 6. There are 2 3's. That's your answer. Now we do a bigger division problem. Suppose you have 75 chocolates and you have 3 people to distribute them to. Okay, how to do? Okay, the point here is this 5 means there are single chocolates. Okay, there are 5 chocolates here. But this 7 means 7 chocolates. No, these are 10s. That means you have 7 boxes of each having 10 chocolates. First, you would distribute single chocolates or boxes of chocolates? Okay, we have to first distribute boxes first and see what is remaining. Right? So, first, we start division with this. Okay, we see 7 divided by 3. Okay, that means, okay, first we distribute these 7 boxes to 3 people. Okay, each one will get how many boxes? 2 boxes, because 3 times 2 is 6. Okay, each one will get 2 boxes, but there is 1 box of 10 chocolates remaining. Okay, one box is remaining, we write it like this, just before this 5, okay, making this 15, because this 1 means it's a box of 10 chocolates and we have 5 more chocolates, total 15 chocolates you have. Now again continue your division. So 15 chocolates, 3 people, each one will get how many? 3 times 5 is 15. So each one will get 5 chocolates and 25 is the answer. Now pause the video and do these division problems yourself. We can do this together. So 96 divided by 4. First we divide 9 with 4. How many 4s are there in 9? 2, because 4 2s are 8. Okay, 9 minus 8. Still there is 1 remaining. Okay, it's like 1 box of chocolate. So actually it's 10 chocolates. Okay, now you have how many remaining chocolates here? 16. So 16 divided by 4. So how many 4s are there in 16? 4 4s are 16 and the remainder is 0. You can write if you want. We have cleanly distributed these 96 chocolates to 4 people. Okay, how about here? So 8 divided by 5. So how many 5s are there in 8? There is only 1 5. Okay, if you take away that 5, still there is 3 remaining. Okay, we write this 3 here and make this as 35. And 35 divided by 5 is how much? 5 7s are 35, you know. So you write a 7 here and there is no remainder. Answer is 17. Much bigger problem. Can you do this yourself just by looking at it with the way we just learnt? Can you do this? There will be a remainder as well. Okay, we can do this together. First, 5 divided by 4. So how many 4s are there in 5? There is only 1 4 in 5. There will be 1 remaining. We put this here. You make it as 17. So 17 divided by 4. So how many 4s are there in 17? 4. 4 4s are 16. Okay. 16 we gave away. So there is 1 remaining because it is 17. So that 1 we put here. And now this is a 19. So 19 divided by 4. So how many 4s are there in 19? 4 4s are 16. 4 5s are 20. Okay, no. 4 4s are 16. Good. Now you gave 16 away from 19. Still, how much is remaining? 3 remaining. You write the remainder as 3. As simple as this. Now we will see how you will do this problem in your regular way. Probably this is how you will be taught in your schools. Okay, we will see the difference. Okay, how you do? So 5 divided by 4 means it's a 1. So 4 times 1 is a 4. So you subtract this. 5 minus 4 is a 1. And then you bring this 7 down here. And then you divide 17 with 4. So 4 4s are 16. So 17 minus 16 is a 1. Then you bring your 9 here. And then 19 divided by 4 means 4 4s are 16. And then you subtract 16 from 19. So it's a 3. So the answer is 144, remainder 3. Okay. So in your exams, if you are asked to tell the answer to this division problem, and if you simply write down the answer without the procedure, maybe they will think that you have used a calculator. Okay, maybe you have to use this procedure to show you know how to divide in your exams. Much bigger problem. Pause the video and see if you can do this yourself. Okay, we can do this together. So we start division here. So how many 7s are there in 3? Oh, there are none. Okay, you can take 2 digits first to divide. Okay, how many 7s are there in 34? Okay, 7 5s are 35. That's too much. So 7 4s are 28. You know. Okay, so 28 chocolates you gave away from 34. Still there are 6 remaining. Okay, you put that 6 here and make this a 65. Okay, now 65 divided by 7. Okay, how many 7s are there in 65? You can see 7 times 9 is 63. Okay, so 9 you put. So 63 you give away from 65. Still there are 2 remaining. So you put a 2 here and this is a 26. How many 7s are there in 26? 3 7s are there. 7 times 3 is 21. You give away 21 from 26. Still you have a remainder of 5. So you write down remainder as 5. This is your answer. Suppose you want to see if the answer is correct or not. How to check? Okay, you have to rewrite the problem like this. So you have given away 493 chocolates to 7 persons and then still there are 5 more chocolates remaining. So this total should be equal to 3, 4, 5, 6. Okay, you have to do this multiplication and this addition to get this answer and then you can confirm that this answer is right or wrong. This is a little tedious. What we can do? The easy way is to use your digit sum check. Okay, how much is the digit sum for 493? So 9 doesn't count for the digit sum. So this is a 7. Okay, 7 times 7 plus 5. Okay, 7 times 7 is a 49. So again you have to take the digit sum for 49. So 9s don't count. So it's a 4. So 4 plus 5 is a 9. Okay, so for this part the digit sum is 9. Okay, now you see how much is the digit sum for 3, 4, 5, 6. Okay, you can see 4 plus 5 make a 9. 9s don't count in digit sum. So 3 plus 6, that's your digit sum. Okay, the digit sums are matching. So this answer is probably correct. Now pause the video and do this division problem by yourself and also check if the answer is correct or not using digit sums. Okay, we can do this together. 7 divided by 6. How many 6s are there in 7? There is only 1 6. Okay, you take 6 away from 7, you have a 1. So that is your remainder here. This becomes a 10. So 10 divided by 6. How many 6s are there in 10? Only 1 6. Take away 6 from 10, you have a 4. So you write this 4 here, this becomes a 48. How many 6s are there in 48? You know 6 times 8 is a 48. So you take away 48 from 48. Okay, there is nothing remaining here. Okay, it's a 0. How many 6s are there in 0? Okay, there are 0 6s and there is nothing remaining here. And then here you have a 9. Okay, how many 6s are there in 9? 1 6. So you take that 6 away from 9, you have a remainder of 3. So this is your answer. Now we will see if the answer is right or wrong using your digit sum check. Okay, I rewrote this problem. So 11801 times 6 plus this remainder 3 should be equal to this. Okay, we will see digit sums of both sides. Okay, on this side, so how much is the digit sum for this number? 8 and 1 add up to a 9, they don't count. You have 1 plus 1 is a 2. So 2 times 6 is 12. So the digit sum is 3 here. Up to this part, the digit sum is 3. And then you have another 3 here. 3 plus 3. So the digit sum is a 6. How about here? 9s don't count in digit sums. 7 plus 8 is a 15. So digit sum for 15 is 1 plus 5. It says 6. Digit sums are matching. So the answer is probably correct. Now pause the video and open page 33 of your workbook. We'll have some fun here. Here you have 9-point circles. Okay, one for each of your multiplication tables from 1 table to 9 table. We know the digit sums can only be in the range of 1 to 9. We will see how the digit sums of all the numbers in each multiplication table will move over this 9-point circle. Okay, I'll give you an example using the multiplication table of 3 and I will draw the pattern. Okay, you have to draw the patterns for other multiplication tables. 3 times 1 is 3. Digit sum is 3. Okay, we start the drawing here. 3 times 2 is 6. Digit sum is 6. Okay, so we move to here. Okay, and then 3 times 3 is 9. Okay, digit sum is also 9. So from here we move to here. 3 times 4 is 12. Digit sum is 1 plus 2, 3. Okay, we come back to 3 here. Okay, 3 times 5 is 15. Digit sum is 6. Oh, 3 times 6 is 18. Digit sum is 9. Okay, if you see, we go in a triangle. So this means all the multiples of 3 will have digit sum of either 3 or 6 or 9. Right? Now this means if you want to see a number is divisible by 3 or not, the easy way is to take its digit sum and see if the digit sum is 3 or 6 or 9, that number is divisible by 3, otherwise not. Okay, for example, you have a number 10002. Is this number divisible by 3 or not? Just by looking at it, we can tell. Okay, digit sum is 1 plus 2, 3. Okay, this number must be divisible by 3. Wow. Okay, suppose for example you have say number 571. Is this number divisible by 3? What do you think? The digit sum is 12 plus 1, 13. So 4 is the digit sum. So this number is not divisible by 3. As simple as this. Now you draw the pattern for the digit sums of 2 times table. That means multiples of 2. Starting from 2 times 1, 2. Okay, you can pause the video or go along with me. So 2 times 1 is 2. We start here. And then 2 times 2 is 4. Okay, we come here. 2 times 3 is 6. 2 times 4 is 8. Then you have 2 times 5, 10. Digit sum is 1. Okay, then 2 times 6 is 12. Digit sum is 3. Okay, 2 times 7 is 14. Digit sum is 5. Okay, and then 2 times 8 is 16. Digit sum is 7. 2 times 9 is 18. Digit sum is 9. 2 times 10 is 20. So digit sum is 2. The digit sums of the multiples of 2 are all over the place. Can we say if a number is divisible by 2 or not by checking its digit sum? No, because the multiples of 2 can have any digit sum. Okay, then how to check if a number is divisible by 2 or not? It's very easy. You know it. Any number you take, say 256. If the number is an even number, it's divisible by 2. Okay, you know what is an even number and what is an odd number? You have to look at the last digit. Okay, if this is an even number means something that can be evenly divided, like that something that is ending with a 0 or 2, 4, 6 or 8. Okay, this is an even number, so this can be divided by a 2. Okay, suppose we have a number 357. Is this even number? Okay, it is ending with a 7. 7 cannot be evenly divided. Okay, so this is called an odd number. So the odd number cannot be divided by 2. Now pause the video and draw the patterns for the digit sums of 4 times table and 8 times table and come back. Okay, did you finish drawing? You would have seen the digit sums of 4 table and 8 table are also all over the place, just like the multiplication table of 2. Okay, so if there is a number, say 3, 8, 5, 7, 6. Okay, just by taking its digit sum, can you say if this number is divisible by 4 or divisible by 8? No. To check if a number is divisible by 2 or 4 or 8, there are many ways. Okay, we'll see one way here. So you know, 2 means it's a 2 times 1 is 2. 4 means 2 times 2. 8 means 2 times 4. Here is a funny thing. Okay, so if you want to see if a number is divisible by 2 or not, okay, what you have to do is you just multiply the last digit with a 1 and see what is this. 6 times 1 is a 6. If 6 is divisible by 2, this number is divisible by 2. Okay, we know this. Now, see, if you want to see if this number is divisible by 4, what we have to do is you have to multiply last digit with a 1 and the digit before it with a 2, okay, and add them up. So 7 times 2 is a 14. So 14 plus 6 is a 20. So 20 is divisible by 4. So this number is divisible by 4. Okay, and if you want to see if the number is divisible by 8 or not, okay, so what we do is you multiply this digit with a 1, this digit with a 2 and this digit with a 4 and add them up. So this is a 20 and here we have a 14, here we have a 6. So this is a 40. So 40 is divisible by 8. So this number is divisible by 8. Now pause the video and draw the pattern for digit sums of 6 times table. Okay, you would have got a similar pattern that we got for the 3 times table, right? All the multiples of 6 will have a digit sum of either 3 or 6 or 9. Does that mean, okay, if a number is having a digit sum of 3 or 6 or 9, that number is divisible by 6. Suppose you have a number 21. Digit sum is 3. Okay, yes, 3 is in this table. So does it mean this number is divisible by 6? No. Then how to check if a number is divisible by 6 or not? Pause the video and think about it. So the hint is 6 is 2 times 3. So to check if a number is divisible by 6 or not, we have to check the divisibility with 2 and also with 3. So is this number divisible by 2? No. So this number is not divisible by 6. This number is divisible by 3, but it is not divisible by 2. Okay. Suppose you have a number, say 3, 1, 1, 2. Is this number divisible by 2? Yes, because it's an even number. Is this number divisible by 3? Okay, check the digit sum. It's a 6. So, this number is divisible by 3. So, this number is divisible by 2 and is also divisible by 3. Therefore, this number is divisible by 6. As simple as this. Now, pause the video and finish drawing the patterns for digit sums of all other multiplication tables remaining. Okay, did you finish? Okay, let's take a look at one by one. Okay, if you see the 5 times table, so the multiples of 5, their digit sums are all over the place. Okay, there is no rule to check if a number is divisible by 5 or not using the digit sum. But you know the easy way to check if a number is divisible by 5 or not is just look at the last digit of that number. As you can see, the multiplication table of 5, all the multiples of 5 will either end with a 5 or 0. So, to know if a number is divisible by 5 or not, you just have to look at the last digit of that number. If that last digit is a 0 or a 5, that number is divisible by a 5. Okay, the next one is the multiplication table of 1. Okay, you would see the digit sums of one table are all over the place. Okay, then how to check if a number is divisible by 1 or not? That's very simple. All numbers are divisible by 1. Good. Okay, and then you see the digit sums of the multiplication table of 9. Did you see the funny thing? All the numbers in the 9 table have a digit sum of 9. So this means to check if a number is divisible by 9 or not, you take the digit sum, and if the digit sum is 9, that number is divisible by 9. As simple as that. Okay, and then comes 7. Okay, the digit sums of the numbers in 7 table are all over the place. Okay, then what is the rule to know if a number is divisible by 7 or not? The exception. The naughty guy has come back. So we will handle all these naughty guys in intermediate level class 1. Okay, meanwhile, if you have any ideas, you can think about it. Okay, so in the intermediate level class 1, we will see how to check divisibility with any number so easily. Okay, that's all for today. Thank you.